Hello and welcome to today's lesson looking at equations. So if you can write the title, Equations, in your exercise book, by the end of the lesson you should be able to identify the reactants and products in a word equation. You should be able to write word equations to represent chemical reactions, and you should be able to convert word equations into formula reactions. Okay? So revisiting what we said last lesson, we can start by defining what a chemical reaction is. Okay, and if I can just plug my graphics board in. So a chemical reaction is defined as a change in which atoms are rearranged to create new substances. Are rearranged to create new substances. Now we can show chemical reactions in word equations and in symbol equations. So chemical reactions can be shown in word equations and symbol equations. Now, word equations are sort of like a shorthand way of showing what happens during a chemical reaction. So a word equation can be defined. So a word equation can be defined as the following: a way of representing a chemical reaction simply. Okay? Now, when we do word equations, we always use an arrow to separate reactants and products. So an arrow, I've put this in red because it's important, an arrow is always used to separate reactants and products in a word equation. Okay? So for the example of word equations we're going to use is the burning of coal. We can start with coal, which we may decide to put on a barbecue with the nice weather coming. Okay? And we can react that coal with oxygen in the air to form another substance known as carbon dioxide, another gas that you may not necessarily be able to see, but that chemical reaction does take place. Now, coal and oxygen would be our reactants. We're reacting coal and oxygen together to make the product carbon dioxide. Okay? So we've got coal plus oxygen to make, oh, if I could spell oxygen, coal plus oxygen to make the product carbon dioxide. Okay? Now, coal and oxygen are our reactants. Okay? They are our reactants. Now, a reactant can be defined. A reactant can be defined as the starting substances in a chemical reaction. Okay, so they are the starting substances in a chemical reaction. Now, reactants are always found on the left-hand side of the arrow. So I'm going to put in red underneath there, found on the left-hand side of the arrow. Now, in the case of this reaction, coal and oxygen are our reactants. So these are our reactants. On the other hand, carbon dioxide would be our product. Now, a product in terms of chemistry is defined as a substance that is made in a chemical reaction. That is made in a chemical reaction. Okay? Now, while products are found on the left-hand side of the arrow, products are found on the right-hand side of the arrow. So products are found on the right-hand side of the arrow. Okay? So a chemical reaction is a change in which atoms are rearranged to create new substances. Chemical reactions can be shown in word equations and symbol equations. A word equation is a way of representing a chemical reaction simply. We always use an arrow to separate the reactants and the products. The reactants are the starting substances in a chemical reaction, and they're found on the left-hand side of the arrow, whilst the products are the substance that is made in a chemical reaction. They are found on the right-hand side of the arrow. In the case that's shown on the screen, we've got coal and oxygen, which are being reacted together. These are the reactants to form the product carbon dioxide. So this would be our product. Okay? We never use an equal sign here. So I'm going to put there, in fact I'm going to put it in red. There is a lot of red on this page, but it's needed. Never use a equals. Okay? You always use an arrow. So let's think about a different example. Okay? Iron is a metal, while sulfur is a non-metal. So iron is a metal, while sulfur is a non-metal. We can mix iron and sulfur together to get a mixture of the two. Now, if we mix iron and sulfur together, we get a substance that looks like this. Okay, it's not a compound, it's simply two elements mixed together. So we can say that iron and sulfur can be mixed together. Now, by mixing them together, iron and sulfur will keep their properties. So, iron and sulfur keep their properties. Now, the reason they keep their properties is because they haven't been rearranged yet. Iron is still iron and sulfur is still sulfur. They're just mixed up a little bit. Now, an easy way to word this is to say that there has been, or there has not been, a chemical reaction. Okay? So there has not been a chemical reaction. If we heat up the iron and the sulfur, we can cause a chemical reaction to form a compound known as iron sulfide, which looks like this. Okay? So we can say that by heating the mixture, we cause a chemical reaction forming iron sulfide. Now, because iron sulfide is a compound, it will have different properties to both iron and sulfur. So we can say over here that iron sulfide has different properties to both iron and sulfur. Okay? Now, iron sulfide is formed in a chemical reaction. So, iron sulfide is formed by heating to cause a chemical reaction. To cause a chemical reaction. Now we could show this in a word equation. We could have iron plus sulfur to form the product iron sulfide. Okay, and we can add our plus in, and we can add our arrow in. Because these are on the left hand side of the arrow, these are our reactants. And because this is on the left hand side of the right hand side of the arrow even, this is our product. Remember, we always use an arrow. We never use an equal sign. So always use an arrow. Okay? So iron is a metal, while sulfur is a non-metal. Iron and sulfur can be mixed together, but the iron and the sulfur keep their properties. There has not been a chemical reaction, but by heating the mixture, we cause a chemical reaction to form iron sulfide. Iron sulfide has different properties to the iron and the sulfur. Okay? The word equation to make iron sulfide is iron plus sulfur, which are our reactants, to form iron sulfide, which is our product. And we always use an arrow to show that. Right then. So another reaction we can talk about is magnesium burns in air, or we can say in brackets reacts with oxygen to form magnesium oxide in a chemical reaction. In a chemical reaction. Now, because it's a chemical reaction, we're taking magnesium, which is a metal, we're reacting it with a gas, oxygen, and we're forming another solid, magnesium oxide. And because this is a chemical reaction, the atoms have been rearranged. So we're adding magnesium and oxygen together, and we're forming the product magnesium oxide. So these are our reactants. And this is our product. Now, as I said, atoms are rearranged, so this is a chemical reaction. So atoms are rearranged, so this is a chemical reaction. Okay? Now, when magnesium is burnt in air, it gives off a white flame and lots of thermal energy. So we can say that the burning of magnesium gives off a bright white flame and lots of heat. Okay? Now, lots of chemical reactions have hazards. So we can say that many chemical reactions have hazards. Okay? Now, a hazard is something that we spoke about in year 7, but it's worth revisiting now, particularly before you start your GCSEs and start having to worry about the required practicals. A hazard, H-A-Z-A-R-D, is defined as a possible source of danger. A possible source of danger. Now, for example, a bright white flame could be a source of danger. So, e.g., a bright white flame. Now, associated with this hazard and associated with any hazard, there will always be a risk. Okay? Now, a risk is defined as the chance of damage or injury, the chance of damage or injury from a hazard. Okay? So, for example, if this is the bright white flame, you could burn yourself or you could hurt your eyes. So we can say, e.g., the bright white flame could burn you or hurt your eyes. So magnesium burns in air, it reacts with oxygen to form magnesium oxide in a chemical reaction. We can show that with the word equation magnesium plus oxygen, arrow magnesium oxide. The reactants are magnesium and oxygen, the product is magnesium oxide. The burn of magnesium gives off a bright white flame and lots of heat. Many chemical reactions have hazards. A hazard is a possible source of danger, such as the bright white flame, and a risk is the chance of damaging something or hurting yourself due to the hazard. For example, the bright white flame could burn you or hurt your eyes. So you should now be able to identify the reactants and products in a word equation. You should be able to write word equations to represent chemical reactions, and hopefully doing the activity that I set you, you should be able to convert word equations into formula equations. If you have any questions at all about this lesson, please let me know via the usual means, and if not, I will see you in the next lesson. Thank you very much.